Okay, good afternoon, everyone. My name is Yang Bo. I'm from Tencent Cloud. I'm a senior AI algorithm researcher, serve as Tencent Cloud now. And in the previous presentation, I'm not sure how many of you are left from the previous presentation. You learned a lot about the trend of the AI. And now, let me take you to the more details and how the AI can achieve, especially the generative AI, in the OTT industry. Next slide, please. So first is the whole overview of the media genre. Our service are, targeted by the three of the E. The enhance the views, the video quality views, and enable the content understanding, the content editing, as well as enrich the interaction between you and the AI model. So this four is just the media genre there. So when we create a video, we need to upload them to the internet. The Tencent provides a quick file upload. It ensures the secure, the swift upload to the cloud. And the media processing, we can do the transcoding there. We increase the quality of the video. We can generate the subtitle automatically, as well as blur some sensitive information in the video, as well as the content recreation. After that, we need to prepare for the streaming, it's both live or video on demand. It's the matter. We need streaming that we provide the adaptive streaming, the time shift features, as well as the server-side ad insertion. And lastly, the network delivery. Our stable network sitting around the world is ensure it's fast and stable delivery the content to every corner of the world. So next slide, please. Thank you. This is my job is mainly focused on that, the media processing part. So in the real world scenarios, we often meet some problems or challenges here. For example, 99% of the video we saw is after the compressed, right? We use a codec to encode the video, then deliver it to the user. User playback, there is the decoder there to view actually what the video it is. So when we do the compression, we always lose something because its size is smaller, we lost the quality actually of the video. There's another one. When we want to distribute our video content to all the world, right? You always met the different languages, barriers. So we need the subtitles here. But doing a subtitle by human is a labor-intensive job. It's really really hard for that. It's pay a lot of effort on that. And the third one, now we always use the cell phone instead of TV to watch the video there. However, the cell phone actually, the aspect ratio is different. When you hold it vertically, it's just like a 60 to 9. When you hold it horizontally, it will be a 9 to 60. So how do we deal with this problem? And lastly is recreation related questions, related challenges. So how could we highlight a football game? I just want the goal moment of the entire football game. How could we do that? And what if the subtitle is already encoded in a video and we want switch to another language of the subtitle? How do we do that? So that can be done during the media processing services and used by AI. Next slide, please. Yeah, I just listed a bunch of problems that I mentioned in previous slides. And actually, we designed a bunch of different AI models to deal with them. You can see that some of them just use a single AI model can totally handle it, but some are not. For example, the quality loss problem. We designed the quality enhancement model to restore the video quality. However, as I mentioned, for example, if you want to erase the subtitle and put a new on that, we need two of the AI models. One is a detection model, and another is the encoding model. Encoding model is known as the generative model. So next slide, please. So let's first see the problem around the transcoding and the quality loss. So why we need transcode the videos there? Why we just watch the original one, with the full quality of the video? Because it's too large. What we do is we want the video can be as small as possible because it will save the storage and the bandwidth cost of the OTT industry, right? If you're a company, you deliver the video content, you always want to save money. But on the other hand, the quality will last more when the video size is smaller. So also, when we do the compression, there might some compression effect exist. You may see some of the blur block in the video. You always see that, right? That's a compression block there. And probably introduce some noise there. As well as when you do watch the news, you always look at the presenter there, not the background. So how do we make the presenter more clear? That's what we do. So next slide, please. Thank you. This is a demonstration video after our processing. Oh, its resolution is really, really bad. However, you can see that the left one is compressed by the open source 264 codec, and the right one is done by our codec. The bitrate is reduced 32%. However, could you see any difference between the quality? Actually not. This looks the same. That's our codec do. So next slide, please. Yeah, when doing the encoding or the codec stuff, there are actually two very, very important challenges. One is what I mentioned. You always want the video as small as possible, but without compromise the quality of the video. The other is we have a lot of the playbacks, actually, the software to play the video. Some of them support different format. So we need our codec to support as much as format. So we can deliver our video to, everyone can watch the videos there. So we optimize our codec. So now our codec can achieve at most up to 70% compression rate. So the processed video will only contain like the 2-5% compared to its original size without compromise the quality there. Also, we support the 8K real-time transcoding. Also, on average, we guarantee the 30%, around 30% more compression rate with our codec. And we, of course, support all the mainstream video codec formats. Yes. So please go to the next slide, please. Yep. And the Apple Vision Pro has announced last year and brings a lot of shock. And how do we deal with the 3D videos in that? During the original approach is we encoding your left eye stream and right eye stream separately, then we combine them together there. And now there is a multi-view HEVC, can use the redundant area or similar area between two streams, and will save 50% more bitrate compared to the original approach. During our test, our multi-view HEVC only take 10% more time compared to the original, but we reduce the bitrate 50% more. So next slide, please. Yeah. After talk about the codec, we need to talk about how we restore the quality loss. Actually, there are also two challenges faced when you want to restore the quality of the video. The first one is the speed. The codec can run on CPU for real time, it's really fast. But how about your AI model? The next challenge is, the different person or different customers prefers different view of the image. Someone thinks, oh, the brighter is better. Someone don't like it. So how could we control the enhancement strength of this? That's what we mainly do. So actually, we carefully design the model structures to make it not too big to run too slow. As well, we also use a lot of approaches to reduce inference time of our AI model. For example, we use the student-teacher approach, let the teacher model to teach the student model. We use the network distillation to make the model smaller, and we only use high precision during the inference to make the model run more faster. Next, sorry, previous slides. One thing, forgot to mention that, yes. For example, and we also separate the enhancement task to a lot of small tasks there. You can see on the right side of the slides. For example, also previous slides, sorry about that. Just a second. Previous slides, please. Yeah. The noise reduction, the detail enhancement, and enhance for your face, enhance for the text, as well as for the low FPS video, the frame interpolation. Now, next slide, please. Thank you. This is a demo video, still cannot be seen the results. Sorry for the low resolution there. Sorry, but this video I want to share a problem there. So when the video resolution is low, but you got a high resolution display or monitor, you will get all the image blur. So how could we deal with this part? Actually, we choose the generative AI to do that. Actually, generative AI is not just the recently open Sora or stable diffusion. It's not just like that. The first one is the VAE, called variational autoencoder, is do the generation. Then it's come to the GAN, right? The generative adversary network. Then it's come to the diffusion model. That is used in Sora stable diffusion that we see. Okay, this one, for do this task, we choose the GAN to do that. We finally control how hard the enhance is there, because if you train again, you know how hard to train that. It's really hard to control that. So we control how hard is the enhancement strength, as well as we reduce the inference time, use the approaches that I mentioned in previous slides. So next slide, please. Oh, this want to show the frame interpolation. So when you have the high, when you have a high FPS monitor, for example, for the 60 FPS, for now the 240 for now max, right? But the video have the lower FPS, it will face the lag problems here. You will see the people works like this, right? So the frame interpolation can help to do that. And there are also the challenges here faced in the frame interpolation. For example, the small movement, for example, I move my hand. If you want to do the frame interpolation between them, it's really hard because it's too small to catch. And another problem is called the non-rigid movement. You can see the curve movements here. It's really hard to recover actually technically. To deal with this problem, we build a large 4K dataset to train our model. We carefully design how we estimate the temporal movement in our models here. And we choose the transformer because it have the attention blocks there to do this frame interpolation tasks. You can see that how smooth you can use through the bottle there, how smooth is there. And you have the a lot of small movement in the basketball game. You can see the results here. So next slide, please. Yes, let's move to the understanding, editing, and the recreation part. So yes, AI can not only do the restoration, but also do some creations here. It can help you to generate whatever the language, the subtitle you want. It can also do the vertical, horizontal conversion of your phone. We have a different approach to do that. It also can help you to blur the sensitive information of the video as well as generate the highlight of the football game. For example, the song, the goal, the save, and the fall, something like that. So next slide, please. This is a demo of our auto subtitle generation. Actually, we first recognize the speech, the voice there, translate, make them into the text. It's in English, and we translate it into Chinese. So we provide two modes of the translation there. One mode is only concern the current sentence. So only one sentence, so it will faster with low latencies here. However, we also provide another mode which have a slice window. It's not only concern the current sentence, but a certain number of previous sentences. So it's more accurate, and you can see that it can automatically correction. All right. So next slide, please. This is our demo for the horizontal and portrait conversion. Usually when you look a video on your phone vertically, the video will be resized smaller, all right? Resized smaller, but it keeps the same aspect ratio. But this makes, it's too terrible to see what's the content in the video. It's too small here. So we choose a more elegant way. We use the saliency detection model in this feature, and it will automatically detect what is the most important area in the video, crop them, and ignore the less important background information. So next, please. This is a demo for our sensitive information occasion. Right? We blur the sensitive information. In this video, we block the face of the people in the videos here. So because now different country has different regulations for that. Some countries won't allow to show the face or something like the plate number. We can also do that. So we do that for that. You can see that in the video, no matter your face is in front of the only side face, it can be accurately detected and blurred there, and no matter whether you are wearing a mask or not. Probably it's easy to see that, right? So next slide, please. And this is our video highlight generation features. We now support the football game. We can generate the highlights, for example, the goal, the save, the fall in an entire, the full length of the football games. Since now people didn't always rush, right? Always so busy to see the entire long video there. Now people prefer to see the short video. For example, the YouTube has the shorts, right? TikTok has the shorts. So we do that feature to let the football fans to see the goal, the fall, the excited moment directly. So next, please. Yeah, this is this feature I really like. It's recently supported by our MPS, the media processing service. That is what we said the erase and impacting features here. If we have a video there, it's already encoded with some subtitles. How do we translate the subtitle to another language, or how do we erase them? So the previous approach is you just make a new subtitles, make a background of the subtitles more dark, and just cover the original one. But we have a smart way to do that. We could erase the subtitle, and we redraw what we erased there, the original pictures from contents there. So it's really better to see is a erasure there, right? So that's the result of the erasing and the impacting. Yes, the last part is as an engineer and as a researcher to talk to our client, we always struggle with different requirements from different clients. This client wants is more light, and this client was more like the dark, the enhancement quality, or don't satisfy about this way. The train is so blurred, so we always met this. So what we thought is, why don't we let the customer directly talk to our models and let the model do that instead of our engineer to do that? So that's the motivation of we want the compiled-like modules here to help us to do the communication or the interaction with the customer. So next slide. So we design a complex and can understanding human natural language module there. And it can understand what's human talk, it can do what the human want the copilot do. So actually, Tencent has its own large language model, LLM, that we already always heard. So our copilot is just talk to the user send the direction, the order to the copilot do a parse, then send the parsed languages, parsed sentence to the LLM. We call that Tencent 混元 LLM. Then Hunyuan gets back of the embedded languages is being vectorized. And the copilot can count and understand and count the corresponding process. Okay, I want to make this video bitrate like lower, the quality higher, make it more bright, make it all have a high contrast, something like that. Then after the process, the copilot can send the result directly to the user. So no more engineering. So we can save the time of our engineer to a more high-level task instead of the repetitive task, like a repeat, and every day. So as still still under developing, and we are hope to bring the showcase soon. So next slide, please. Yes, all the features that I mentioned in this talk are supported the SDK, which can be deployed locally on the client's own machine. Also, we support the which called the hybrid deployment. User can use their own, like for example, the AWS for storage, no matter. Then send the just the content want to process to us, and we do the process, send back to the AWS. No problem about that. It's really flexible. So next slide, please. So yes, this just want to show each logo there is really familiar with the industry. We're all familiar with this. But each logo is represent 100 people, year-to-year effort working on that. So it's really hard to the beginning to build our own like OTT platform all by themselves. So Tencent will provide the help. We have more than 20 years experience on that. And also, we are not only care about our own business. We have contributed a lot to our community, to the FMPAC community. Every year, we have already submit like over 800 patches here. Yes, we are the top 10 contributing to the community for like several years, 4 years, 5 years. And also, we had served as a CSOG mentor in the 2 consecutive years. And at the same time, we joined a bunch of the standard organization. And Tencent is the only founding member of the AOM organization, actually, in China. So next slide, please. Yes, the last slide. Yes, you can have the try by yourself on our website, mps.live. And our booth is at the West Hall 3830. So welcome to take a more like high resolution results there. It's not like a project one. So yeah, that's probably my talk. And thank you for coming. Thank you for coming.